Okay, now we will go through for the 5 rules for sketching the root locus. So the next 5 rules allow us to sketch the root locus using minimal calculations. The rules yield a sketch that gives intuitive insight into the behavior of a control system. In the next section, we refine the sketch by finding actual points or angles on the root locus. So the first rule for sketching the root locus is number of branches. Each closed loop pole moves as the gain is varied. If we define a branch as the path that one pole traverses, then there will be one branch for each closed loop pole. Our first rule then defines the number of branches of the root locus, where the number of branches of the root locus equals to the number of closed loop poles. As an example, look at figure rule 1. Okay, there are 2 poles, okay, -3 and -4, meaning that there are 2 branches as shown by the red lines. This is the root locus branches. Okay, rule number 2, symmetry. If complex closed loop poles do not exist in conjugate pairs, the resulting polynomial formed by multiplying the factors containing the closed loop poles would have complex coefficients. Physically realizable system cannot have complex coefficients in their transfer function. Thus, we conclude the root locus is symmetrical about the real axis. An example of symmetry about the real axis is shown in figure rule 2. So this is from our rule number 1. Okay, we have 2 poles and 2 branches. So we have symmetrical about real axis. It goes upward and downward. Same goes to this one, it goes upward and downward because of symmetrical about the real axis. This is your real axis. Okay, rule number 3, real axis segment. On the real axis, for k larger than 0, the root locus exists to the left of an odd number on real axis, finite open loop poles or n finite open loop zeros. Okay, highlight this point, exists to the left of an odd number on real axis. Okay, from right side, we have this one as the first roots, this one second, third and 4th. Okay, no matter whether this is pole or 0. Okay, from the from the right side, this is first roots, second, third and 4th. Okay, first and third is the odd number on the real axis. Okay, this is for real axis roots. First and third is odd, second and 4th is even. Okay, again, this statement mention that root locus exists to the left of an odd number on real axis. So this is the odd numbers. So for these roots, okay, the odd number of roots, the root locus exists to the left. Okay, exists to the left. So the root locus will connecting between the first and second roots. Okay, the next one, this is the odd number. The root locus exists to the left of an odd number on real axis. So the next root locus path connecting between the third and 4th roots. Okay, so this is rule number 4. Okay, using rule number 4, starting and ending point states that the root locus begin at the finite and infinite poles of GH and ends at the finite and infinite zeros of GH. In simple sentence, root locus begin at poles ending at 0. Okay, root locus begins at pole, ends at 0. So using the rule number 4, we find that the root locus begins at the poles at -1 and -4. Okay, so root locus begins at poles and end at zeros between -6 and -7. Okay, thus the poles start out at -1 and -4. Move through the real axis space between the two poles. Okay, they meet somewhere between the two poles, okay, at this point, and break out into the complex plane. Okay, the symmetry about the real axis. Okay, moving as complex conjugate upward and also downward, and then the poles return to the real axis. Okay, the poles return to the real axis somewhere between zeros -6 and -7 at this point, where their path is completed as they move away from each other, one to the right and one to the left, and end up respectively at the two zeros of the open loop system at -6 and -7. So the root locus begin at poles and ends at zeros.